All right, welcome back to Mr. P Helps with Precal. This is Unit 2, Topic 2, Lesson number 1. We are going to start solving log equations. So in the last topic, we focused on all the different properties of logs, and we're going to use a lot of those properties in order to solve these equations. Starting off with solve the following basic equations. So by changing them to, so these are exponentials, and we're just going to change them to the same base. This is already 3 to the power of x minus 1. Now 81 could also be changed to base 3, so 3 times 3 is 9, times 3 is 27, times 3 is 81. So this is really 3 to the 4th power. Now, what you've done in the past is that anytime the bases are the same, then the exponents must also be equal to each other. So that x minus 1 equals 4. And add 1 to both sides, and that tells you that x is 5. All right, so for this one, same thing. So we're going to first set them both to the same base. So 128 is the same as 2, 4, 8, 16, 32, 64, 128. So that's 2 to the 7th power. So we have 2x minus 3 equals 10. Add 3 to both sides, and you've got 2x equals 10, which tells you that x must be 5. We found x. All right, so this one, we have division first. So that's 10 to the power of x equals 40. Once we have it to this point, okay, so we cannot, in this case, there is no power here that's going to be equal to this. So the inverse of to the power of would be log. So I'm going to do log of both sides. So log of base 10 of 10 is going to be equal to x. So technically the answer is log of 40. And I'm just going to leave it right there because that's going to be an irrational number, which of course you can put into the graphing calculator and it'll tell you a rough estimate. So d, in this case, I'm going to add 3 to both sides, and that gives me e to the 2x power is equal to 10. Now, the inverse of exponentials is ln, which stands for natural log, which is really log base e. So log base e of e. So these basically just cancel out in this case, but whatever I do to one side, I have to do to both sides. So I end up with 2x equals natural log of 10, and then divide both sides by 2, and there's your answer. X equals natural log of 10 over 2. Now keep in mind that you cannot divide these because this is of natural log of 10. So this is not really just a coefficient, so just keep that in mind. You can't simplify this like you can like a normal fraction. All right, solving these equations, and I'm going to break this up into 2 videos. I'm going to leave all the questions that require condensing in order to solve for the next video, and we're going to stick to just regular basic solving in these, sort of like you solved regular equations back in Algebra 1. So we have log base 3 of x plus 1, but I'm going to throw in a little twist here. So one thing I showed you on the last video with I think it was change of base video, is exponentiating. So the opposite of log base 3 would be 3 to the power of. So if I do 3 to the power of and 3 to the power of over here, so it's exponentiating, which means I'm making 3 the base, and I'm taking what was already there and making it the exponent. Because like I did before, if the bases are the same, then the exponents must also be equal to each other. Well, I'm just doing the same thing in reverse, basically. And anytime this base is the same as this base, was the reason why I'm using 3 as the base of the exponential, is because it makes these two the same. So these basically cancel each other out. You're left with just x plus 1 equals 3 to the 4th power. Well, 3 to the 4th power, if I simplify that, 3, 9, 27 becomes 81. Subtract 1 from both sides, and you've got 80 as the answer. Now, something very important to keep in mind here is that you might have extraneous answers, because there are rules to log functions, and we're told that the x is never allowed to be a negative, nor is it allowed to be 0, because no base to any power will ever equal 0, because even a base to the power of 0 is going to equal 1, not 0. And no base to any power can ever equal a negative. So x has to be a positive number. So that's important that whatever I get here, this doesn't necessarily have to be positive, keep in mind, but when I plug it back in here, it does need to be positive. And if it's not positive, then it's an extraneous solution, therefore it does not make sense in the context. So even though algebraically it solves, it's still not really an answer. 80 plus 1 is fine because that gives you 81, and that's right. So 3 to the 4th power is 81. That does make sense. I've kind of just checked my answer. All right, so I'm going to exponentiate this one as well because it's log base 4. So the 4's kind of cancel out. You're left with x minus 5 equals 4 to the negative first power is 1/4. Now I add 5 to both sides and I get x equals 5 and 1/4. Now if I put that in here, 5 and 1/4 minus 5 does give me something that's greater than 0. Not by much, but it does. It's going to give me 1/4. So this is a real solution. It's not extraneous. This one, so I'm going to first divide both sides by 20. I got to get rid of this multiply first. And that's going to give me 1/2 to the x over 3 power equals 1/4. Now I can change 1/4 to the same base. So I'm going to have 1/2 x over 3 equals 1/2 to the second power because 1/2 times itself is 1/4. Now that the bases are the same, x over 3 equals 2. The exponents must also be equal to each other. And then last step, just multiply both sides by 3, and then you've got 6. Now, of course, this is in exponential format. So as long as the base isn't a negative, then you're pretty much fine. Nor can it be 0, of course. It has to be a positive number. So you can have negative exponents. So really, I don't need to check for extraneous this time because the exponent can be a negative and it still is a exponential equation. For this one, I'm going to divide both sides by 3. So that gives me 5 to the x over 4 power equals 125. Now 125 can be changed to base 5 because that's 125 is really 5 times 5 is 25 times 5 again. The third time would equal 125. Now the bases are the same, so we have x over 4 equals 3. Multiply both sides by 4 and you've got 12. Now once again, I really don't have to check for extraneous because even if the exponent is a negative, that's still an exponential equation. It's only the base that's not allowed to be a negative, nor can it be 0. All right. Time. Yeah, I got time. So this will be my last 5. Now, like I said, I'll do another video of ones where you have to condense and solve as well. So this time, 5 is being multiplied by log base 2 of x minus 3. So remember, you do order of operations backwards when you solve equations. So PEMDAS is how you evaluate expressions. But when you are solving equations, you have to do them in the opposite order. So multiply comes before, in this case, which is kind of like parentheses. So divide both sides by 5, and that gives us log base 2 of x minus 3 equals 3. Now, the next step is to exponentiate because we have this log base 2, and the inverse of that is 2 to the power of. Now we have 2 to the power of on both sides, so these kind of cancel out. You're left with x minus 3 equals 2 to the third power, which ends up being 8. Add 3 to both sides, and you've got x equals 11. Now, it's always important to check, yes, you have to check for extraneous solutions because whatever I get as my answer can't make this a negative, and it's not. So 11 minus 3 is going to be a positive number, so this is good. This is a real answer. Let me change colors here. So the next one, I would have to subtract 3 from both sides. So that gives me 2 times e to the negative 3x power equals 18, and then divide both sides by 2. Keep in mind, I got rid of add first, and now I'm getting rid of the multiply next. So that leaves me with e to the negative 3x power equals 9. Now, the next thing I'm going to do is get rid of this exponent, and the way I get rid of the exponent is by getting rid of the base e, and I'm going to do the inverse of that, which will be natural log of both sides. That cancels out there, and that leaves you with, I'm running out of room here, negative 3x equals natural log of 9. I could put this in the calculator, but I'm actually going to leave it the way it is because that's the most precise. And then the last step I have to do is divide both sides by negative 3. So the x equals natural log of 9 divided by negative 3. All right, it is exponential, so don't need to worry about extraneous in this case, and exponents can be negative anyway, so it's no big deal. All right, next question. So we got to subtract 4 from both sides. That gives us 3 times 2 to the power of x equals 21. Then divide both sides by 3. So 2 to the power of x equals 7. And I want to get rid of the base 2 of exponential, and the inverse would be log base 2. So doing log base 2 of both sides, and this cancels out. So x equals log base 2 of 7, which is the same thing as x equals log of 7 over log of 2. If you use change of base, of course. And I'm going to run out of room here. A lot of these are taking quite a bit of room. Divide both sides by 36 first. So that gives me 1/3 to the x over 5 power equals 4 times 9 is 36. So that's 1/9. Now 1/9 can be converted to base 3. So 1/9 is really 1/3 squared, and now we have the same bases. So x over 5 equals 2. Multiply both sides by 5, and x equals 10. Not a log function, so I don't need to worry about extraneous. All right, and last one. So divide both sides by 2, so you get 10 to the power of negative x over 3 equals 10. So they're both the same base. This is really 10 to the first power, so we can cross those off. We have negative x over 3 equals 1. Multiply both sides by 3, you got negative x equals 3. And then multiply both sides by negative 1, you got x equals negative 3. Once again, put negative 3 in here, makes it positive 3. 3 divided by 3 is 1. 10 to the first power times 2 is 20. Yeah, just check the answer. It does work. All right, thanks again for watching. I am going to make one more video, like I said, with solving equations with condensing. And those questions are going to take a little bit more time, so there won't be as many of them. Thanks again for watching. Have a great day.